Hello everyone. In today's lecture, we will talk about what is known as linkage methods. Yesterday we discussed distance functions. So we saw that given any two objects, we can find distance between those two objects by any one of the distance functions that we discussed. In fact, as I mentioned, there are many more distance functions and we can use them as and when needed. Now, but the question comes what to do when I want to compute distance between, say, two groups of objects, okay? Because we saw in the basics of clustering algorithms that we might, okay, if I'm talking about, say, hierarchical agglomerative, then initially I have every object separate, then we try to club few of them together. Okay, so maybe at first step I have clubbed these two guys together, maybe at next step I have clubbed these two together, this is still here and then this is still here and so on. So when I want to do that, what we are going to do is, of course, intuitively you will be clubbing objects which are close to each other. Okay, so those objects which have minimum distance. So at the initial stage, fine, we compute distance between all the objects. But what if I want to compute, when I go to next step, I'm having this one cluster which is coming from these two objects. Okay, so this cluster has two members whereas the others are individual. And now I want to decide which of these clusters should be put together. So I need to compute distance of this group from each of these individual objects or observations. Correct. At the next step, now suppose I have fused these two, then I want distance between this group and this group to decide my further stage. Okay, so basically we need a way to find distance between a group and a single observation or distance between two groups. Okay, so far what we know is just distance between two individual observations. Okay, so distance between two individual observations we will compute via some distance function, but we need to know what to do with these. Okay, distance between a group of observations and a single observation, or distance between two groups of observations. Okay, so that's where linkage methods come into picture. So again, there are various linkage methods, but we'll be seeing only a few of them which are widely used. Okay, so first let us talk about what we have. So suppose I have one group, let's say G1, and I have another group, let's say G2. Suppose I have three objects here. Let me call them A1, A2 and A3. So three objects in group 1, and suppose I have two objects in group 2. Let me call them B1 and B2. And we want to find distance between these two groups. And let us assume that we know the individual distances between all the observations. So I know distance of A1, A2, A1, A3, A2, A3, A1, B1, A2, B2, all these things. Okay. So to find distance between G1 and G2, I need to have some formula. Now, what are few of the obvious things that come to your mind? Maybe the most basic thing is try to take some sort of average distance. Okay, so what do I mean by average distance? So let us see how many possible distances are there when I go from group G1 to G2. So I may have to go from A1 to B1 or A1 to B2. Another possibility is A2 B1. Another possibility is A2 B2, and then A3 B1 and A3 B2. So there are basically 6 possible distances, correct? So I can take my distance between the two groups as average of these 6 distances. Okay, so I may write this as 1 by 6 distance A1 B1 plus A1 B2 plus A2 B1 plus A2 B2 plus A3 B1 plus A3B2. Correct? A few things to be noted. We are not using distance between A1, A2 or A1, A3. We have those distances, but we are not using them because once they are inside a group, once they are inside a same group, it's like we are treating them as a single object. So we worry only about distances of observations from one group to this observations from other group. Okay. So we are ignoring distance B1, B2 also. Okay. So this is actually known as average linkage. Okay. This is known as average linkage method. In general, I can write distance between G1 and G2 if I want A1, A2, AM. So let me say G1 consists of A1, A2, AM, and suppose G2 consists of B1, B2, BK. Okay. I'm trying to generalize. Then distance of G1, G2 will be 1 upon M into K, because total number of connections will be M into K, sum over I, sum over J, distance between AI, BJ, J goes from 1 to K, I goes from 1 to M. Okay. Is it okay? This will be the formula for average linkage. So you take all the distances and then you average over those. Some other ways include maybe considering just the shortest possible path. Okay. So that would be called as single linkage. So what does single linkage method do? Let me try to draw picture again. So this is suppose my G1. This is suppose my G2. I have say A1, A2, A3 here suppose, and then B1, B2 here. Then let us try to find the shortest distance between G1 and G2. So suppose it is between this A2 and B1. Then we take distance of A2, B1 as the distance between the two groups. Okay. So in general, distance of G1, G2 with the notations that we described here would be minimum over I going from 1 to M, J going from 1 to K, distance of AI, BJ. Okay. So single linkage method says that take the distance between two groups as the shortest possible distance. Okay. Next is something called as complete linkage. So if you consider shortest possible, why not longest possible? So if I have this as G1 and this as say G2, suppose I have A1, A2, A3 here and B1, B2 here, then maybe the largest possible distance is suppose A3, B2. Then we take distance between the two groups as distance between A3 and B2. So in the earlier notations, I could write this as maximum over 1 less than equal to I less than equal to M, 1 less than equal to J less than equal to K, distance between AI, BJ. Okay. The largest possible distance. Okay. So this is complete linkage. So far we have discussed three methods: average linkage, single linkage, complete linkage. Okay. Now, some of you might have felt that instead of instead of taking average of the distances over here, why not maybe find some sort of a central point over here, a central point over here, and then take distance between that. Okay, this could be one possible suggestion, and that gives rise to the next linkage method, which is known as centroid linkage. Okay, centroid linkage. So what do we do in centroid linkage? As I just described, suppose I have group G1 here and I have a group G2 here. Suppose these are my three objects, A1, A2, A3, B1, B2. Then first we find a center point of that group. Okay, so here A1, A2 are given here, A1, A2, A3 are here. So if I take average of A1, A2, A3, I'll be somewhere here. So this, let me call it C1, center of the first group, and B1, B2 are here. So their average will be somewhere here. So let me call it C2, center of the second group. Then we will say distance between G1, G2 is same as distance between C1, C2, the two centroids. Hence the name centroid linkage. So where C1 is equal to sum over AI is I going from 1 to M upon M. So average, and by the way AIs can be vector, right? Don't forget that. So whatever is the dimension of each AI, same will be the dimension of C1. Similarly here. So this will be J going from 1 to K upon K. Okay. So you might have realized that centroid linkage cannot be used if you have categorical data, especially nominal categorical data, because you can't compute average over there. Okay. And so this is known as centroid linkage. Now these are 4 linkage methods, but of course these are not the only ones. You can propose any number of modifications. So instead of say taking simple average, you could take median of all possible distances. Okay, that could be median linkage. Then instead of taking centroid as a mean, you could take centroid as a median and then compute distance. That is also possible. So there are various ways in which distance between two groups can be computed, or distance between one group and one observation, because we could simply treat that observation as a group and everything else is same. Okay. There are more advanced linkage methods, for example Ward's linkage, which we are going to study, but we will learn it in the context of the actual cluster analysis algorithm. Okay, because right now explaining it without going to cluster analysis is difficult. One more important concept we need to know when we are dealing with cluster analysis is distance matrix. Okay, so what is a distance matrix? So you have object 1, object 2, object n. Suppose you have n observations, then you create an n cross n matrix which would serve as a distance matrix. So in general, if I call this matrix as D, then Dij, ijth entry of D would be distance between OI and OJ, ith observation and jth observation. Now by the definition itself, the diagonal entries of the distance matrix would be 0, correct? Because they are distances of the objects from themselves. So diagonal entries would be equal to 0, no doubt about that. And what can I say about off diagonal entries? First of all, they have to be non-negative, correct? Because they are distances. So off, or maybe I can simply write Dij is greater than or equal to 0 for every ij. Okay. And because we know that the distance function is symmetric, distance between OI, OJ is same as distance between OJ, OI. Hence, Dij is equal to Dji, and therefore D is a symmetric matrix. Okay. Distance matrix is a symmetric matrix. Okay, so far? We are going to need this distance matrix in especially in the hierarchical clustering. Okay, so please keep these properties of distance matrix in mind. Okay, so what we have done so far, we have studied a few distance functions. Euclidean, Manhattan, and trivial were the ones where we discussed more details, but you can find many more distance functions in the books. And then today we discussed linkage methods, which could be used for computing distance between one group of objects and another group of objects, or one group of objects and another single object. Is it okay? So this is where linkage methods will be used. If it's alright, then let me stop here. Thank you.